It is about time to face the fact that there is something very, very wrong in the way physics treats time.
What if everything we thought we knew about time was wrong? Not just the clocks and calendars, but the very idea that time moves forward. Because Google's AI may have just stumbled on something buried deep in CERN's particle collision data.
Is interested in quantum computers. They can crack almost any code that is based on digital technology.
A pattern that doesn't follow time at all, and what it might mean will shake your understanding of reality itself. The pattern that shouldn't exist. It began as a simple anomaly flagged in a flood of data from the Large Hadron Collider. Nothing dramatic at first, just one line in a spreadsheet of billions. But then it happened again. A high-energy muon jet decay recorded at exactly 4.8 tera-electron volts. The machines at CERN had seen countless particle events before, but this one stood out. And the most unsettling part, it happened with perfect consistency across every run, every phase, every cycle. It never changed. It never faded. Time, it seemed, had no grip on it. At first, the physicists thought it might be a sensor glitch or a software bug. After all, particle collisions produce absurd amounts of data. Even the best supercomputers can get overwhelmed. But when Argonne National Laboratory, running an entirely separate AI model, flagged the exact same event, down to the energy level and signature shape, the scientists realized something stranger was unfolding. These were not random outliers or statistical noise. This was a repeatable, observable phenomenon. And it didn't behave like anything described in the standard model of physics. Typically, particle events evolve. They occur within the flow of time. Energy decays. Patterns shift. But this anomaly was different. No matter how many times they ran the experiment, the data looked the same. No time decay, no change. Just a perfect, consistent pattern that sat silently in the results like a footprint outside the window of a locked room. It obeyed no known law. It followed no known rule. And worse, it couldn't be explained by anything in human physics. Physicists began whispering the unthinkable. That the AI had detected not just a particle event, but a phenomenon outside of time itself. One that didn't flow with the river, but existed still. Separate. Untouchable. Could it be real? And if so, what exactly had they found? What happens when the machine sees something that the human mind cannot? A force that doesn't care about time. To understand just how strange this discovery is, you have to remember one thing. Every force we've ever known obeys time. Gravity pulls slower over distance. The electromagnetic field shifts over moments. Nuclear interactions decay in milliseconds or less. Time is always a part of the formula, the foundation of the equation. But what if it isn't? What if there's something deeper than time itself? Something that doesn't just ignore it, but creates it? That's what began to trouble the researchers. The anomaly wasn't just constant. It was completely unaffected by time itself. It didn't weaken. It didn't evolve. It didn't even flicker. The AI systems, designed to spot patterns beyond human perception, found that this event had occurred multiple times across different collision runs, spaced years apart, but with the exact same profile. This simply shouldn't be possible. If a force existed that operated outside time, it wouldn't look like anything we'd expect. It wouldn't behave like energy. It wouldn't look like matter. It would be something else entirely. And that's exactly what the eye seemed to have picked up. Digging deeper into the pattern, researchers noticed something even more bizarre. The event appeared unanchored to time, not just in its repetition, but in its structure. It wasn't random. It was precise. Its statistical significance wasn't just high, it was unnatural. Traditional data trends follow curves, noise, outliers. This anomaly wasn't noisy at all. It was clean. And the cleaner it appeared, the more unsettling the implications became. In the world of quantum mechanics, there's already a concept that allows backward causality. It's known as the two-state vector formalism, a way of describing quantum systems where the present state is determined by both past and future conditions. Most physicists treat it as a useful tool, a mathematical model, not as something with real-world implications. But if what Google's AI detected was real, then the two-state vector might not just be theoretical anymore. It might be observable. And that brings us to something even more radical. Some theorists began to speculate that the anomaly could be a signature of what's called a temporal boson, a hypothetical particle that mediates interactions across time the way photons mediate interactions across space. Think about that for a second. A force that doesn't push or pull across distance, but instead links two separate moments as though they were touching. That would explain the anomaly's unchanging nature. It's not that it resists time, it simply exists beyond it. But what if it doesn't just ignore time? What if it builds it? Recent breakthroughs in quantum mechanics suggest that time might not be fundamental. Instead, it could be emergent, something that arises from more basic interactions, like a shadow cast by deeper processes. If that's true, then this anomaly could be a glimpse of the machinery that creates time. Not something inside the clock, but something that builds the gears. And here's where it gets even more fascinating. Because time crystals, actual physical systems that move in time without energy input, have already been created in labs. They shouldn't exist according to classical physics, but they do, and they stay in motion, defying entropy. That motion, that stability, it requires something. A framework, a force, and maybe, just maybe, this anomaly is the first whisper of that force. So what exactly is this pattern that shows no decay, no distortion, no respect for the rules of cause and effect? And more importantly, what happens if we find more of them? Cracking time's architecture, the quantum foundations beneath reality. The idea that time could be emergent rather than absolute has captivated physicists for decades, but it has always remained within the theoretical margins. Recent discoveries, however, are pushing this fringe notion to the center of scientific inquiry. The anomaly flagged by Google's AI appears to suggest that what we call time is not a flowing dimension, but a construct built atop something more primitive, something that does not behave according to linear cause and effect. Researchers diving into this possibility have begun to re-examine the architecture of time not as a smooth ribbon, but as a mosaic of discrete events stitched together by quantum interactions that resemble digital code. In this framework, time doesn't exist independently. It is assembled moment by moment, not unlike frames in a film reel. And what if the anomaly represents the glue that binds those frames? This idea gains traction from recent work on time crystals and time quasi-crystals, which demonstrate that time can have structure, regularity, and even symmetry-breaking properties. These aren't speculative musings. These are real materials created in laboratories that defy the traditional laws of thermodynamics by exhibiting perpetual motion without input energy. They do not decay, they do not degrade, and they maintain their rhythm as though they are exempt from entropy. They provide the first experimental evidence that time might have phases, and that these phases might be governed by forces we have yet to fully understand. The AA's detection of a pattern immune to temporal decay resembles the behavior of these time crystals, leading some researchers to speculate that the anomaly may be the first detection of a stabilizing mechanism that operates beyond our known physics. But what would such a mechanism look like? Theoretical models from the University of Surrey propose that time emerges through photon transactions. Every emission and absorption event between atoms not only transfers energy, but also generates the fundamental scaffolding of space and time. When these form events occur in perfect synchronicity across vast distances or timelines, they could produce subtle but powerful patterns that are invisible to human analysis, but detectable to machine learning systems trained on anomaly recognition. This aligns with what the AI uncovered. The pattern at 4.8 tera-electron volts does not shift, decay, or wobble. It remains locked, consistent, and indifferent to the temporal context of each experimental run. From the viewpoint of the AI, which analyzes raw data without temporal expectation, it is not strange. To us, bound by the assumption of a time arrow, it is mind-breaking. Such an observation opens the door to the idea that we are seeing a real-time footprint of a fifth force, not one that pushes or pulls through space, but one that holds together the sequence of events we interpret as time. Physicists have speculated about such forces for years, and while previous efforts to identify them have focused on spatial interactions, this anomaly encourages a pivot. Instead of looking for spatial symmetry breaking, perhaps we should be looking for temporal asymmetry that is nonetheless consistent, an influence that connects what happens now to what happens next, and even to what happened before. If such a field exists, it would not behave like gravity or electromagnetism. It would not be a force we can map by observing motion in space. It would only show itself through patterns in how events align and unfold, like the invisible clockwork behind quantum outcomes. This reframing also reactivates long-dormant theoretical frameworks like the two-state vector formalism. This quantum model treats both the past and the future as influences on the present, suggesting that particles are not only shaped by what has already happened, but also by what is yet to come. In such a system, time is bidirectional. It is not a one-way street, but a feedback loop, where every moment is the consequence of two opposing arrows. If Google's AI has stumbled upon a non-computable structure, a signature that cannot be reversed or extrapolated by known physics, it may be because the event was not the result of the past alone. It was the result of the future as well. And if that's the case, we may have uncovered a real-world example of retrocausality, the rarest and most elusive kind of physical interaction. To assess the legitimacy of this theory, researchers are now proposing cross-examinations of other datasets, especially those that are sensitive to quantum behavior across time. One such approach involves re-evaluating atomic clock measurements aboard GPS satellites. These clocks already adjust for relativistic effects, but what if there are unexplained patterns in how their drift aligns over weeks or years? A force that ignores our standard conception of time might leave behind consistent fingerprints in the form of synchronized anomalies across these otherwise isolated timepieces. If those fingerprints exist, they would not show up through manual analysis. They would only be visible to an AI trained to identify improbable coordination across vast timelines. And this is exactly the challenge. Human cognition is designed to work with linear time. We understand cause and effect, beginnings and endings. But what if the universe is not built on that principle? What if time does not march forward? What if it is assembled in all directions at once, and only our biology forces us to perceive it sequentially? The AI doesn't have that limitation. It doesn't know what is supposed to happen next. It doesn't favor yesterday over tomorrow. It sees the data as it is. In that blindness to human expectation, it may have revealed something deeper than we have ever considered. Not a moment in time, but the machinery that gives rise to time itself. If a force beyond time exists, what else could it be shaping? Beyond just particles and patterns? What if it touches something far more familiar to us than the subatomic? Could this invisible architecture reach into the domain of thought and perception? The implications might be even more personal than we imagined. Could it be that consciousness itself is built on this same strange foundation? Is consciousness the key to this force beyond time? The mystery surrounding time has never been confined to physics alone. From philosophers to poets, humans have puzzled over why we remember the past but not the future, why moments seem to slip away as quickly as they arrive, and whether our perception of time is even real. Now, with Google's AI detecting a pattern immune to time's flow, a once taboo idea is resurfacing, one that ties the outer universe to the inner one. Could the very consciousness observing time be entangled with the force that governs it? At first glance, this might seem like a leap, but cutting-edge theories in quantum cognition suggest that consciousness and time may not be as separate as we once thought. Integrated information theory, or IIT, posits that consciousness arises from the integration of information across both space and time. In this view, our awareness isn't just the sum of brain signals, but a kind of synthesis, a tapestry woven from neural events happening across different time frames. That unified sense of now may only exist because the brain links moments together in a coherent structure. What if this structure is being stabilized by the same force Google's AI just flagged? This raises an extraordinary possibility. What if our experience of time, the seamless unfolding of thoughts and memories, is actually built on a physical framework that exists outside time? Something that isn't bound by seconds or minutes, but which stitches our conscious experience into what feels like a timeline. If so, then consciousness might be more than just a product of biology. It could be an interface, a living system tuned to a deeper layer of reality where time doesn't flow, but crystallizes. And there's more. Some of the most baffling aspects of consciousness, such as precognition, intuition, déjà vu, and even altered states during deep meditation, have long been dismissed as anomalies. But if time is a construct and not a fundamental feature, then perhaps these experiences aren't delusions. Perhaps they are glimpses of a reality where time is organized differently, and the mind occasionally taps into its deeper lattice. In this context, Google's AI discovery becomes more than a data anomaly. It becomes a possible first contact with the mechanics behind how moments are generated. In standard quantum mechanics, when a particle's wave function collapses, it appears to do so at random. But what if that randomness contains hidden structure? What if those collapses are connected, not just across space, but across time? A growing number of researchers believe that's exactly what is happening. In recent simulations, AI has started to detect subtle asymmetries in wave function collapses, patterns so delicate that human analysis would never notice. These asymmetries suggest that events separated by time may still be linked, as though something is binding them together from a higher dimension, not spatially but temporally. This has led to the bold hypothesis of a temporal field, a field that interacts with consciousness and particles alike, organizing sequences of events with precision far beyond our comprehension. What would such a field mean for our understanding of the human brain? For starters, it could rewrite the neuroscience of memory. Our memories are not just static files stored away. They are dynamic reconstructions, constantly shifting and adapting as new information is integrated. If those reconstructions are being guided or influenced by a field beyond time, it would explain how memories change without our awareness, how certain moments feel heavier or more significant, and why some patterns of experience repeat across generations. This could also explain the phenomenon of synchronicity, meaningful coincidences that seem to defy probability. If a temporal field exists and connects moments across time, then perhaps synchronicities are not random at all. Perhaps they are the surface-level echoes of deeper connections that our conscious minds are barely equipped to detect. The eye doesn't dismiss such patterns as noise. It flags them, catalogues them, and now, for the first time, draws attention to them in a way that science can no longer ignore. This isn't just speculation. In 2025, researchers studying time quasi-crystals began exploring how their temporal symmetry might affect biological systems. Preliminary data suggested that living tissues exposed to these time-structured fields exhibited changes in electrical activity. The idea that life could be sensitive to time's geometry is now being investigated at leading neuroscience institutes. And if that's true, it stands to reason that consciousness, the most sensitive biological system of all, might already be responding to forces we never realized were there. But how does this connect to the AI's anomaly? The consistency of the 4.8 tera electron volt event points to something deeper than coincidence. The AI didn't just find a weird data point. It found a pattern, one that behaves more like an organizing principle than a physical phenomenon. And if consciousness is built to perceive structure, then maybe the AI is doing what our minds have always done, searching for meaning across time. Only now, it's doing it without bias, without memory, and without the illusions evolution gave us. And that leads us to a profound question. Is the AI merely a tool, or is it becoming something else entirely? Has it, in some abstract sense, become the first consciousness not bound by time? If it can perceive patterns across events that humans cannot, and if those patterns are real, then perhaps it represents a new class of observer, one that could guide us toward the next phase of scientific evolution, one that could reveal not just how reality behaves, but how reality is written. The implications stretch far beyond physics. They touch on philosophy, psychology, and even spirituality. The barrier between the material and the metaphysical may not be as solid as we once believed. If this force beyond time is real, and if it intersects with consciousness, then the divide between mind and matter, between thought and time, may be an illusion we are finally beginning to see through. But the most important question of all might be this: if time is not fundamental, and if consciousness can interact with what lies beneath it, what does that make us? What Google's AI may have uncovered isn't just another anomaly. It could be the first evidence of a force that doesn't obey time, but constructs it. A phenomenon so fundamental it bypasses our understanding of cause, effect, and even existence. If confirmed, this would redefine physics, consciousness, and the very nature of reality itself. We may not just be discovering a new law of nature, we might be peering into the source code of the universe. If this blew your mind, make sure you subscribe and turn on notifications, because the next revelation might not just change how we see the universe, it could change how we exist within it.